How did Hurricane Otis form and intensify so rapidly? Why couldn't anyone forecast its track and impact accurately? And what does this mean for the future of hurricane prediction and preparedness? Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today we are going to talk about Hurricane Otis, the most powerful and destructive storm of the 2023 Atlantic hurricane season. Hurricane Otis was a rare and unprecedented event that shocked the world with its ferocity and devastation. It formed as a tropical depression on October 22, 2023, in the southwestern Gulf of Mexico, and quickly strengthened into a tropical storm the next day. It then moved westward towards the coast of Mexico, where it underwent explosive intensification, reaching Category 5 status on October 24, with maximum sustained winds of 165 miles per hour and a minimum central pressure of 923 millibars. This was the second fastest intensification rate ever recorded in the Atlantic Basin, behind only Hurricane Wilma in 2005. Otis made landfall near Acapulco, Mexico on October 25th as a high-end Category 4 hurricane with winds of 155 miles per hour. It caused catastrophic damage to the city and surrounding areas, flattening buildings, uprooting trees, flooding streets, and cutting off power and communication. The storm also triggered landslides and mudslides that buried entire villages. Hurricane Otis has killed 39 people so far, making it one of the deadliest hurricanes in the country's history. But Otis was not done yet. After crossing over Mexico, it re-emerged over the Pacific Ocean, where it regained strength and became a Category 3 hurricane again. It then took an unusual turn to the north-northeast, heading towards the Baja California Peninsula. It made a second landfall near Cabo San Lucas on October 26th as a Category 2 hurricane, bringing strong winds, heavy rain, and storm surge to the popular tourist destination. It then continued to move along the coast of Baja California, weakening to a tropical storm before dissipating on October 27th. The total damage from Hurricane Otis was estimated at over $50 billion, making it one of the costliest hurricanes on record. It also affected millions of people in Mexico and the United States, who had to deal with the aftermath of the storm's destruction and displacement. Many people were left homeless, injured, or missing. The humanitarian crisis caused by Otis prompted an international response from various governments and organizations who provided aid and assistance to the affected regions. So how did Hurricane Otis become such a powerful and unpredictable storm? What factors contributed to its rapid intensification and erratic behavior? And why were the forecast models unable to capture its evolution accurately? To answer these questions, we need to look at some of the latest research and studies on hurricane science and climate change. One of the main factors that influenced Otis's development was the extremely warm ocean water in the Atlantic and Pacific basins, where it formed and traveled. According to the National Oceanic and Atmospheric Administration, both basins experienced above-average sea surface temperatures in October 2023, which provided more fuel for Otis to grow and intensify. The warm water also increased the amount of moisture in the atmosphere, which enhanced Otis's rainfall potential. Another factor that played a role in Otis's rapid intensification was the lack of wind shear in its environment. Wind shear is the change in wind speed and direction with height in the atmosphere. It can disrupt or weaken hurricanes by tilting or tearing apart their circulation. However, Otis encountered very low wind shear throughout its lifespan, which allowed it to maintain a well-organized structure and a symmetrical eye. A third factor that affected Otis's track and impact was the steering flow around it. The steering flow is the large-scale pattern of winds that determines where hurricanes go. It is influenced by various atmospheric features such as high-pressure systems, low-pressure systems, jet streams, troughs, and ridges. In Otis's case, it was steered by a combination of these features that changed over time. When Otis formed in the Gulf of Mexico, it was initially steered by a high-pressure system over Texas that pushed it westward towards Mexico. However, as it approached landfall near Acapulco, it encountered a trough of low pressure over northern Mexico that turned it slightly northward. This caused Otis to make landfall at an oblique angle, rather than perpendicular to the coast. This reduced its frictional interaction with land and allowed it to retain more of its strength as it crossed over Mexico. After emerging over the Pacific Ocean, Otis was steered by a ridge of high pressure over western Mexico that pushed it westward away from land. However, as it moved further westward, it encountered another trough of low pressure over California that turned it sharply northward. This caused Otis to make a second landfall near Cabo San Lucas and then follow the coast of Baja California. This increased its interaction with land and caused it to weaken gradually as it moved northward. These changes in the steering flow around Otis were not well predicted by the forecast models, which had difficulty capturing the timing and strength of the troughs and ridges that influenced Otis's path. As a result, the forecast models had large errors and uncertainties in projecting Otis's track and intensity, especially beyond 3 days. This made it challenging for the forecasters and the public to prepare for Otis's impact, especially in areas that were not used to experiencing such strong hurricanes. Hurricane Otis was a remarkable and unprecedented storm that challenged our understanding and prediction of hurricanes. It also highlighted the need for more research and innovation in hurricane science and climate change. A recent study by Yale University suggests that the 21st century will see an expansion of hurricanes and typhoons into mid-latitude regions, which include major cities such as New York, Boston, Beijing, and Tokyo. The study attributes this to the warming of the planet as a result of greenhouse gas emissions, which will create more favorable conditions for tropical cyclones to form and intensify over a wider range of latitudes. Another study by the University of Florida proposes a novel machine learning framework to predict hurricane-induced building damage using data-driven methods. The study uses building hazard and geospatial data to train different algorithms to estimate the damage that buildings will experience during hurricanes. The study aims to support decision-making for community stakeholders and improve the resilience of buildings to hurricane hazards. These are just some examples of the ongoing efforts to advance our knowledge and capabilities in dealing with hurricanes and their impacts. Hurricane Otis was a wake-up call for us to pay more attention to these complex and dynamic phenomena that affect millions of lives and livelihoods around the world. It also reminded us of the importance of being prepared and informed before, during, and after a hurricane strikes. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.